Okay, so it says up here at the top, underlined with a little star by it, don't forget, if special right triangles occur, your answers need to be exact. All right, so not all these will come out to be special right triangles, but even if we're dealing with trig stuff, if you know it's a special right triangle based on the side lengths or based on the angles, your answers need to be in exact form because they can be. When we do the trig on the other ones, it's because they can't be, so that we have to do it and have the decimals. So this says, Julie's math class is modeling a ladder sliding down a wall by using a jumbo craft stick with the rounded ends removed, making it exactly 13 centimeters long. So basically, they're using a popsicle stick with the ends cut off. At the beginning of the experiment, the stick will be against the wall. The base of the stick, which is on level ground, will be pulled away from the wall at 1 centimeter every 10 seconds to simulate a constant rate of 1/10 of a centimeter per second. 1/10 of a centimeter per second. So A says, draw a diagram of the situation, label all fixed quantities with their value, label all moving parts with a variable, and draw an arrow to show the direction of movement. So when this experiment starts, the stick is up against the wall, so it's like two parallel lines. But then as it starts to move away from the wall, it's going to create a right triangle as it moves away. So when it asks you to draw a diagram of the situation, it's not at time equals 0, otherwise it doesn't even look like a triangle. Okay? So you're going to draw a right triangle so that it's some time has passed. And it says label all fixed quantities. What is a fixed quantity? What does that mean? Okay. Well, I can be specific with a lot of things, though. What would make it a fixed quantity? Okay. But it's not an answer. It says a fixed quantity. It will always be that. It's fixed at that. It's something that doesn't change. So as this is sliding down the wall, there are things that are changing, there are things that are not changing. So the things that are not changing are the fixed quantities, and they need to be labeled with their value. And then we label all moving parts with a variable and draw an arrow for the direction of movement. Okay, so I'm going to give you a minute to do that. Think about what that says and try and get your triangle drawn. Okay, and then I'll come up here and make sure that we all get it drawn correctly. Okay, so when I draw this, if yours is reflected around the other way, it's fine. I mean, my right angle is going to be on the left. If your right angle is on the right, it's totally okay. So here's my triangle. What would my fixed quantity be? 13 centimeters, because the length of the craft stick isn't going to change, right? So that is 13 centimeters. And then my right angle also is not going to change. But as this slides down the wall here, this length is going to change and this length is going to change. All right, so I'm supposed to label those with a variable. I'm going to call this one X and this one Y. It really doesn't matter which is which. Sorry if yours is opposite, but I would suggest maybe you change it so it matches mine so you're not confused, but that's up to you. And then the arrow for the direction of movement. So as it slides down the wall, this length is going to decrease. This length is going to increase. And then we have a rate of 1/10 of a centimeter per second. What is changing at that rate, X or Y? Okay, this says the base of the stick, which is on level ground, will be pulled away from the wall at 1 centimeter every 10 seconds. Will be pulled away from the wall at 1 centimeter, 1/10 of a centimeter per second. This is your rate here. Now, do you think that X is also changing at that rate? I'll tell you that you don't really have a great basis to know for sure one way or the other. So it really is just a what do you think kind of a question right now. So have you ever had something like if we were pretending like this was maybe one of those dividers or a yardstick or something that was literally sliding down the wall while you were trying to go grab it. Like as you reach for it, since it is sliding down the wall, and all of a sudden when you get close to it, it just goes bam and it hits the ground because it seems like it's sped up as you were going for it. That ever happened to you when things are falling? Okay. Well, it doesn't just seem like it sped up. It did speed up. So this is being pulled away at a constant rate. The rate at which this is changing is not a constant rate. This is an increasing rate. This rate of change changes. Okay? So that seems a little weird, but that's what's happening here. So if you think about that, by the time this is laying on the floor, it's going to have to move, one of these two is bigger than the other unless it's an isosceles right triangle, right? So these two things both have to change from whatever they are to, 0 at the same amount, in the same amount of time, but they have a different distance to go. So one of them is going to have to be different. This is a constant rate. This one is actually an increasing rate. Okay, so increasing rates are not something that you really have dealt with yet, as far as slope and rate of change is concerned. Overall, it's more of a big calculus topic, but it is something that we kind of touch on. Mainly right now, just for you to understand that rate of change can change, which seems a little weird. That's why these are called related rates. They're not the same rates, but they are related to each other. That's what the purpose of this activity is. It doesn't do a great job of actually pointing that out to you through these problems, so it's something that I have to kind of come back and do after we work through them. So we'll get through this one, and then you're going to work through the rest of them on your own. All right, any questions about this picture? We all good? You understand all those pieces on there is what it was asking you for. All right, so now it says when the base of the stick is 5 centimeters from the wall, what is the angle between the top of the stick and the wall? All right, so I'm going to redraw my picture, but I don't necessarily need to redraw all of this stuff. I'm just going to go ahead and redraw my triangle. And then it says when it is 5 centimeters from the base of the wall, or the base is 5 centimeters from the wall, so that's 5 centimeters. This I know doesn't change. That's my 13 centimeters. I don't have to necessarily put the arrows back in, and I don't even have to put X on there because it doesn't ask me for X here, so putting extra stuff might just be confusing. It says, what is the angle between the top of the stick and the wall? So do I want this top angle or the bottom angle? The top, because it says the top of the stick and the wall. But I'm not going to call it X because I already have an X in there. I have a Y in there. I could call it Z, but I'm not going to do that either. Because when you get into the upper level math and science classes, your unknown angles, you don't use variables like X, Y, and Z, A, B, and C, that sort of thing. You use some other things that I've told you, I think, once and drew it. I don't even think I made you write it down. I just kind of pointed it out to you. And it looks something like this. That's not a circle. Well, to draw it, it's a circle with a line through it. But it's not an O. It's not a circle. Anybody know what that is? No. It's a Greek, no, it is, I just said it is not a 0. It is a Greek letter. Anybody know what Greek letter that is? It's like a variable. Since it's a Greek letter, it's a variable. This is the Greek letter theta. Okay? So theta is like, so in anything you've done up until this point, a default unknown for you, like if you don't know what something is, you can put an X on it as long as there isn't one there, right? So for the upper level stuff that we do, your unknown angles, we don't use X. Your default for your unknown angle, or the most common for it, doesn't have to be, is theta. So this angle that I want, I'm going to call it theta. All right? Just theta. Theta is something in degrees. Okay? So now I can solve this, and this is, can't do, Pythagorean theorem or anything else like that. I'm going to have to use some trig. So this is my what? Opposite. This is the what? Hypotenuse. What uses opposite and hypotenuse? Sine. So this is the sine of what? Theta. Good. Equals the opposite, which is 5, over the hypotenuse, which is 13. So do I multiply both sides by 13? No. What do I do? The sine inverse. Good. So I do the sine inverse of both sides, which means theta is equal to the sine inverse of 5 over 13. So theta equals what? Okay. So this is what I got. Now, if you did get something like 0.39, can you have an angle measure that is that small?
Never mind. I forgot to.
Okay, but listen to my question. Can you have an angle measure that's that small, like 0.39? Yes, you absolutely can. But if that angle measure was that small, then this side length would be super small in relation to this. Like it might still be 5, but this would have to be like 50 million or something, right? But 5 and 13, this isn't super small compared to 13, which makes me think that something isn't right, like a mode, or maybe you hit the wrong key or whatever. So, but don't just think because you get something super small like that that you're automatically wrong, because you can have an angle like that. It's probably not going to happen in a situation like this, but that is definitely possible. At some point, that angle is going to be that small as this comes down. All right, so we get 22 point, I already forgot, 620, right? Okay. Now, just like if I was to just solve for x here, nobody asked me for x, nobody asked me for theta. We put that in there, right? So I have to answer the question. And AP, true AP style is I need to make it an actual sentence to say that the angle, and you can abbreviate, you just have to make sure it makes sense, and you can use mathematical symbols, but the angle between top of stick and wall is 22.620 degrees. You have to be able to verbalize your answer, even verbalizing it in writing. Because there are times where y'all can get an answer, you have a number, and I say, okay, what does that number represent? You're like, I don't know, I did the math, this is what I got. But you really have no clue what it even means. So that's one reason why you actually answering it and saying what it is important. Everybody good with that so far? Okay. So now on C it says, when the base of the stick is 5 centimeters from the wall, what is the measure of the angle? Okay, so let's go ahead and redraw this again. This is still 13 centimeters. This is 5 centimeters. This was my theta. And now I'm looking for this angle right here. Well, just like if I've already used x, I really can't use x again. I've already used theta, so I really can't use theta again. So your next most common, again, doesn't have to be, but the next most common thing used besides theta for your angles looks like this. It's like looks like a fat Jesus fish. Okay, that is the Greek letter alpha. It's like the A of the Greek alphabet. So that's the lowercase alpha. So we're going to use that. I'm just going to practice using some of these so there's no little fat Jesus fish. Looks like a what? Looks like part of it too, yeah. Probably. Okay. All right, so can I do some trig to come up with alpha? Yes. Do I have to do trig to come up with alpha? No. Okay, but I have to communicate what I'm doing, and I can't just have an answer there. So what I can do, yes, you can do the trig, and there's nothing wrong with that. You could totally do that and be fine. But what does alpha and theta have? What do they have to add to give me? 90. So I can say that theta plus alpha equals 90, which means alpha, which is what I really want, is just 90 minus theta. Now, you can manipulate the calculator where you don't have to actually store this, but we're going to store this to practice. So this should be the last thing that's in your calculator, right? Because I should never use my rounded answers. So I'm going to store this. Now I can store it anywhere I want, but I want to make sure that it makes sense to me. And if you look here, what you usually use for x, look, this says x, t, theta, n. Because depending on the mode of the calculator, which is not a mode that we're going to be in this year at all, but this actually could pop up and be theta for you. Theta is something that you could be graphing depending on what type of graphing that you are doing. So I'm just going to go ahead. It's going to say x right there because of the mode we're in, which is fine. If you wanted to put it in t for theta because that made more sense to you, whatever. As long as you know where it is, that's all that really matters. So I'm going to store it in there. So now that I have that and I know that alpha, which is what I want, is just 90 minus theta, I can do 90 minus theta, which is going to pop up as x, but it's the same thing. And I get that. So alpha equals 67.380 degrees. Everybody okay with that? Then I have to answer the question. It says, what is the measure, blah, blah, blah. So I have to say the measure of the angle between the base, oh my goodness, what the heck? The base of the stick and ground is 67.380 degrees. Okay, everybody good with that? now it says at the end of 70 additional seconds, what is the measure of the angle between the base of the stick and the ground? Okay, so this additional seconds is important. When time is 0, the stick is up against the wall, so it doesn't even make a triangle. So when the base is 5 centimeters away, some time has passed. So this is saying after that, 70 more seconds. So here's my triangle. Okay, so what I had was, this is 13 centimeters, and it doesn't change. This was at 5, but now I have to add some more stuff to it. So this is going to be 5 plus something, because it's getting farther away. Now, this is not a difficult conversion. I realize that most of you can just look up there and just like know what it is. But have you ever done converting for things and you multiplied when you should have divided or vice versa? The answer is yes, don't lie. You know, you've all done it at least once. Some of us do it all the time. Because it can get confusing. Like sometimes they're super easy and it's obvious, but then sometimes you're like, do I multiply, do I divide? And you reason through it and you go back and forth and then you don't know anything, right? So if you can understand what to take it back to, and that'll work every single time, it can be super duper helpful. Always, always, always take anything that is a rate, like centimeters per second, miles per hour, whatever, make it into a literal fraction, even if it comes out to, even if it's a whole number. Now this is a fraction, we'll look at what happens with whole numbers, but this is 1/10 of a centimeter per second. So that means I get 1 centimeter for every 10 seconds. Okay, and if I actually write that, units and all, not just a number, but units and all, then it's a proportional relationship. I'm not actually converting like from seconds to minutes or anything like that. I'm just trying to figure out what happens after 70 seconds. So I know that this is actually 70 seconds, and then this is some sort of centimeters. Now you can cross multiply and divide, but you really don't even have to go that far all the time. Sometimes once you set it up that way, it should be kind of obvious. If this is 7 times more than this, then this has to be 7 times more than this. So what's the number that goes here? 7, plus then this would reduce. Like you don't have to actually do the math because you can just see what's happening. The numbers aren't always that pretty, and sometimes you really do need to cross multiply, but at least it's set up then, and bam, you can figure out what you need, right? Set up, please. All the way up. All right, so that's my 7 centimeters. Now, just another side note. Let's say that it's 5 miles per hour. Because I said this the other day in pre-cal, some of them were like, oh, and I'm thinking, wow, all the way through chemistry and half of physics, and you didn't realize how easy this stuff is. So 5 miles per hour. Yes, that's a whole number. It's not even a fraction. But if I needed to convert that to seconds or feet or whatever, before you start deciding I'm supposed to multiply, I'm supposed to divide, I have to do this one and this one and this one, just understand that you can make this 5 miles for every 1 hour. That's what it means. Okay, and so once you have it that way, if you need to do some dimensional analysis, you can multiply to convert things, or it could be a proportional thing and just know that, you know, you have miles and hours, so if it was like 20 hours, I could figure it out easily that way. That way you don't ever get yourself mixed up between multiplying and dividing, because y'all can do proportions. All right, so just think of it that way. It makes it way, way easier. All right, so with all that said, I know that this is 5 plus how much? 7, which means altogether now this is 12 centimeters. And now I am looking for the measure of the angle between the base of the stick and the ground. So this one. Now I've already used theta and alpha. So this is a separate part of the question. So really I could reuse theta, but we might as well talk about some of the other ones. So after alpha, the next most common then is beta. So it's like the B of the Greek alphabet. It looks like a curvy capital B with a tail like that. It's the best I can do. Again, you make effort. It's not really a capital B. The capital beta actually looks like a capital printed B. This is like a more curvy, fancy B with a tail. Okay. Like a bee popsicle, yes. All right, so this is beta. Now, I need to do some trig, right? This is which side? Opposite, adjacent, or hypotenuse? Adjacent. So this is adjacent. This is hypotenuse. What uses adjacent and hypotenuse? Cosine. So the cosine of beta is equal to 12 over 13. So beta is the cosine inverse of 12 over 13. So what do you get for beta? 22.620, right? Does that seem weird? Yeah, because isn't that the same answer for your theta, which was the angle up here before it moved an additional 70 seconds, right? Okay, so I've moved 7 centimeters this way. This was 12, so I've also moved 7 centimeters this way, so it's 5. But remember, I told you that the rates are different. So I want you to think about this. As this is sliding down, if this is 12 centimeters, how many more centimeters do you have to go before it hits the ground? This way. How long is the stick? 13. So it's just one more centimeter, because my picture's not really to scale, right? Which is fine. It doesn't matter, because you didn't know how to draw it when we started. But if this is at 12, if I pull it away and it's now 13 centimeters, this is going to be laying on the ground. You agree with that? So I have 1 more centimeter go. But if this is now at 12, this right here is now 5. So although I have 1 more centimeter to go this way, I have 5 more to go this way. So that little bit more it's going to go is going to make the rest of that go, bam, really fast. And that's what I meant by, if something's coming away from the wall, it seems like it's speeding up. It is. It's not speeding up coming this way, but it's speeding up going down the wall. Make sense? Constant rate of change, increasing rate of change, okay, which is what we end up calling instantaneous rate of change. Because if I find the rate of change where it's here, it's different than it's here, but rate of change on all of this would be the same. So this is like a linear and this is non-linear type of thing if you were to graph it. Okay, so just kind of exposing it to you is all we're really doing here. But I still have to answer the question. So my question now then, or my answer, it says, what is the measure? So I have to say, the measure of the angle between the base, oh my gosh, I'm trying, like, I do the base, and my H turns into a B. All right, the base of stick, bad English, but that's okay, and ground is 22.620 degrees. Did you have a question? No? Oh, I heard a what? All right. Everybody okay with all that? Any questions? All right. My suggestion to you on the rest of this would maybe to be try and get the pictures drawn before you work the whole problem while you're working with each other. That a lot of times, because once you get the pictures, I think y'all can handle the trig. You proved that on that test. But remember, if it turns out to be a special right triangle from the side lengths or from the angle measures, your answers need to be exact. And then, yeah, that's it. So get as much of it done as you can. You can ask me questions today. And then tomorrow, if you have any quick questions on this so you can get it finished up, we'll do that. Okay? Any questions right now? All righty.